Hi class, it was brought to my attention that the videos for section 7.2 objective 2 don't match up in my math lab, so I wanted to create a little video for you for your guided notes so you could understand what was going on. You can also get this information out of the textbook. So in this section we're talking about something called the discriminant, and the discriminant we get from computing a certain part of the quadratic equation. So imagine we have an equation in standard form where we have ax squared plus bx plus c equals 0. Well, if we just take the expression b squared minus 4ac, we can use that expression called the discriminant to make some decisions about what might happen with the solutions of our quadratic equation. So this should look familiar to you because it was the portion under the square root in the quadratic equation that you just learned in the previous section. So what we don't want to do is fall into the habit of always using the quadratic formula when we're solving quadratic equations. There's a lot of room for error in the quadratic formula, lots of negatives floating around, and if there's a better way to solve the equation, we want to kind of focus on the most efficient way to do it. And so the discriminant is a way that we can kind of predict what's going to happen to the outcome of our problem. So we're going to look at different possibilities for the discriminant and then see if that can help us decide the best way to solve a quadratic equation. So here's our quadratic equation down here, and the discriminant again, b squared minus 4ac. If we take a second before we try to solve and just observe some things about b squared minus 4ac, we might be able to pick the best way to solve the equation. So let's imagine that we look at when the discriminant is positive. So we compute b squared minus 4ac, we get some positive number. If that positive number is a perfect square, then the best way or the most efficient way to solve the equation is by factoring. I don't want you guys just using totally the quadratic formula all the time. I want you to think about what's going to be the best way to do it. If you get b squared minus 4ac and it's not a perfect square, then that means we can't factor it over the set of integers, and so we should complete the square or use the quadratic formula in that case to solve the equation. So that's what we do if the discriminant is positive. If the discriminant equals 0, exactly 0, then we should be able to solve the equation by factoring. And what will actually happen here is we'll get one answer instead of two. We'll see that in a second. And then what's interesting is that if the discriminant is negative, then we have two complex solutions. This means that we have a negative discriminant. We're going to use the quadratic formula if it's a perfect square, and we're not going to use factoring unless we get to college algebra and feel really comfortable factoring over imaginary numbers. So in this class, you'll probably use quadratic formula for all of these problems. But the reason I want to talk about this is that if you think about when you looked at the quadratic formula, if this portion was under the square root symbol, then we talked about what that does. It creates an imaginary number. And so in a quadratic equation, it creates two imaginary or complex solutions. So I'm going to show you how this works in some examples where we can use the discriminant to predict what's going to happen and then choose the best way to solve it. So the first thing we want to do when we look at this quadratic formula is determine, should we jump to the quadratic formula or should we try factoring? And that's not easy to see just by looking. So we take a look at a, b, and c, the coefficients of our variables, and plug them into the discriminant over here. When I plug that in, I get a positive 169. 169 is a perfect square, so that means I should be able to factor this quadratic equation, excuse me. So over here is my equation. I'm going to use the AC method, so I multiplied 2 times negative 15, and I'm looking for factors of negative 30 that add up to 7, and I chose 10 and negative 3. So I took my trinomial quadratic equation, split up the 7x into 10x minus 3x, and then I can factor by grouping. So here I'm factoring by grouping. I pulled out a 2x from the first two terms, and I pulled out a negative 3 from the second two terms, and sure enough it factored right here, x plus 5 times 2x minus 3. Using the zero property, I split up each of these factors, and I found that my two solutions were x equals negative 5 and x equals 3/2. So the discriminant helped me to determine that I could factor this, and that I did not need the quadratic formula to do it. So let's look at some of the other cases of what the discriminant might give us. And on the next page of your notes, we have an equation, 3x squared minus 4x plus 2 equals 0. So again, we don't want to jump to the quadratic formula automatically, but we may need it. Spoiler alert, I guess you can see that we are going to need it. But anyways, a equals 3, b equals negative 4, c equals 2. So using my coefficients into the discriminant, I find out that I have a negative 8. This gives me two complex roots. It's not a perfect square, and we're not in college algebra, so we haven't learned how to factor over complex numbers yet, but that means we're going to use the quadratic formula. So here's my quadratic formula, x equals negative b plus or minus b squared minus 4ac over 2a. I very carefully pay attention to the signs and input all my values. So x is negative 4 plus or minus the square root of negative 4 squared minus 4 times 3 times 2. Now if you're very clever, you would have already realized you just did this over in the discriminant. But I did it again anyways. Got 16 minus 24 under my square root and negative 8. So I want to simplify this answer. I'm going to break up the square root of negative 8 into negative 1 times 4 times 2, which means I can pull out the square root of 4 and the square root of negative 1 as 2i from my radical sign there. Cleaning up just a little bit more, I can do 4 over 6 plus or minus 2i radical 2 over 6, and reducing those fractions, I get 2/3 plus or minus I radical 2 over 3. Here's your two complex solutions. You have the positive and the negative. You can write it like this or like this. Now, not on your sheet was an example where the discriminant is 0, so I added it. This is not on the sheet you printed out. But I just wanted to show you what happens when the discriminant is 0. So again, 9x squared minus 6x plus 1 equals 0. You might be unsure of whether or not you should factor or use the quadratic formula. So we can pull out those coefficients and do a quick check over here. It turns out here that when we do the discriminant, we get 0. So that plus or minus portion, if we were to do the quadratic formula, wouldn't even be in there, which means the quadratic formula isn't really necessary. We're going to get one rational solution, so we should try factoring. So again, I'm going to use the AC method. I take factors of a times c, 9 times 1, and I want to choose them so that they sum up to b, negative 6. So I'm taking my 3-term quadratic equation and turning it into a 4-term quadratic equation by removing negative 6x and including negative 3x minus 3x here. Then I factor by grouping. I removed a 3x common factor from the first pair, and I removed a negative 1 because I had a leading negative coefficient, and so I factor out the negative 1. And that works out because I end up with 3x minus 1, 3x minus 1. Both of these are going to turn out to give us the same solution, x equals 1/3. So we end up with just one solution. Our final answer is 1/3. So I wanted to show you what happens when the discriminant equals 0, even though it wasn't on your notes. So I'm sorry that those videos didn't exactly sync up, but I hope this is helpful to you as you work through these problems in your notes.